At the dawn of the 20th century, Germany reigned supreme in the field of airship construction. Humanity was captivated by the idea of conquering the skies, and the sight of massive airships drifting above the clouds embodied the technological wonder of the age. These hydrogen-filled giants symbolized progress, and Germany became the land where this dream was turning into reality. At the heart of this movement stood visionary engineers and inventors. Ferdinand von Zeppelin, Johann Schutte, and August von Parseval dedicated their lives to building machines that could transport passengers and open new frontiers for science, commerce, and travel. Their ambitious projects were driven by peaceful intent. Airships were envisioned as a new mode of transportation that would connect cities and nations. Ferdinand Zeppelin began his work in the late 19th century. His concept focused on creating rigid airships, vessels built with a sturdy internal frame capable of carrying heavy cargo and large groups of passengers over long distances. Zeppelin didn't just build ships, he built an industry. His early models, such as the LZ-1, were impressive in size and potential, even though they required significant refinement. Johann Schutte explored alternative designs, experimenting with non-rigid airships. These were lighter but more vulnerable to weather conditions. August von Parseval developed semi-rigid airships that combined the benefits of both approaches. Each engineer had a unique vision, but all were united by the belief that airships could change the world. In this period, airships became a source of national pride and a symbol of technological progress in Germany. They drew the attention of engineers and the general public alike. Flights over cities like Berlin or Friedrichshafen turned into grand spectacles, attracting thousands of spectators. Airships carried passengers and mail and even supported scientific experiments at high altitudes. Both the government and private companies poured vast resources into the industry, recognizing its commercial potential and its value in enhancing Germany's prestige on the world stage. By the first decade of the 20th century, German airships were operating regular routes, and their designs were improving constantly. Engines grew more powerful, envelopes more durable, and control systems more precise. This golden age was filled with optimism. The engineers behind these flying giants dreamed of peaceful skies and new ways to bring nations closer together. Zeppelin envisioned transatlantic journeys that would drastically reduce travel time between Europe and America. Schutte saw airships as a means to explore the Arctic and other remote regions. Parseval experimented with cargo delivery to hard-to-reach areas. Everything pointed to the dawn of a new era where technology would serve humanity. But peaceful enthusiasm was shadowed by political tensions. Early 20th century Europe was a powder keg of growing rivalries. Though airships were originally designed for peaceful purposes, their potential soon caught the attention of the military. Their size, long flight duration, and cargo capacity made them attractive for military use. Strategists began to see airships not just as marvels of science, but as tools of war. This marked a turning point. Dreams of peaceful skies gave way to a new reality, where airships would become instruments of power. Germany, the technological leader, was soon to bring its innovations to the battlefield, where new and grimmer challenges awaited. At the beginning of the 20th century, the German military saw airships not only as a technological marvel, but as a potential weapon of war. The first steps toward their military use date back to 1884, with the formation of the first balloon unit in the Army. This small unit operated tethered observation balloons, large hydrogen-filled spheres anchored by ropes. These balloons were used for artillery spotting and enemy reconnaissance. From several hundred meters in the air, they offered visibility far beyond anything ground scouts could achieve. Artillery crews could fire more accurately, and commanders gained better awareness of enemy positions. This early use of aerial platforms laid the foundation for future developments. But tethered balloons had severe limitations. They relied on ground anchoring, were vulnerable to wind and enemy fire, and couldn't maneuver. The military realized that real air superiority required a new kind of machine. In 1906, 8 years before the outbreak of World War I, the Army received its first true dirigible. It marked a decisive shift from static balloons to fully steerable airships that could fly independently, climb to higher altitudes, and perform complex missions. These craft allowed the military to observe, transport supplies, conduct long-range reconnaissance, and, at least in theory, attack enemy targets. Germany's military leadership quickly embraced the idea. The single balloon company expanded into 5 full battalions, Two of these had their own dedicated airship training schools. Crew training was rigorous, requiring knowledge of navigation, meteorology, and teamwork. Airship crews included pilots, engineers, observers, and mechanics, each with a vital role. By 1913, Germany's army possessed 9 operational airships, a formidable force that reflected the nation's growing ambitions in aerial warfare. Each ship was a technological marvel, up to 150 meters in length, capable of reaching speeds of 80 km/h, and filled with thousands of cubic meters of hydrogen. Strategists explored their use for reconnaissance, resupply missions, and even bombing raids. Although actual bombing missions were still rare at this stage, the concept was already taking shape. No other nation had such a fleet of steerable airships. Germany held a clear advantage. Meanwhile, the Imperial Navy, favored by Kaiser Wilhelm II, also grew interested. But the Navy's inexperience with airships led to disaster. In a matter of weeks, its newly formed aerial division lost all its airships in 2 separate accidents. These crashes destroyed equipment and claimed the lives of most of its trained aeronauts, leaving the fleet without an air arm. The setback was devastating, but it became a catalyst for change. A young lieutenant named Peter Strasser was appointed to rebuild the naval airship program. At the time, he was relatively unknown, but he would soon become a central figure in the history of military airships. With determination and vision, Strasser set out to restore the naval fleet, recognizing the airship's potential to change naval warfare. His appointment marked the beginning of a new era of intensive training and preparation. By this point, the need for military airships had become undeniable. They were to become the eyes of both Army and Navy, offering a view of the battlefield unreachable from the ground. Despite early failures, Germany doubled down on its efforts, investing in new machines, training personnel, and developing strategies. This sense of necessity, born from the looming threat of war, would guide the transition of airships from peaceful dreams to tools of brutal conflict. When Germany's airships entered the age of war, they faced a test they were not prepared for. Their first combat missions revealed both the potential of these sky giants and their fragility in real battlefield conditions. Despite high hopes placed on them by German command, the initial foray into aerial warfare made it clear that technological superiority alone was not enough. The harsh reality quickly outpaced the optimistic plans drawn up in military headquarters. The first combat use of airships actually came from the Italians. On March 6, 1912, during the Italo-Turkish War, 4 Parseval-type airships launched bombing raids against enemy positions. This became the first recorded use of steerable airships in offensive operations. Over dozens of sorties, Italian crews dropped bombs on fortified positions with mixed results. The psychological effect, however, was immense. Soldiers on the ground, witnessing explosives falling from the sky, often panicked. To them, the airships seemed like supernatural machines, unreachable and unstoppable. Yet the physical damage caused by these early raids was minimal compared to the immense cost of operating and maintaining the airships. The lesson was clear: airships could be tools of terror, but their actual battlefield effectiveness was still questionable. Germany, observing Italy's operations, chose to forge its own path. In 1914, with the outbreak of the Great War, German airships were sent into combat for the first time. One of the earliest missions involved the Army's Z-6 airship, tasked with reconnaissance over the Belgian city of Liège. But instead of triumph, the Z-6 met brutal resistance. French artillery opened fire with precision. The envelope was riddled with holes, hydrogen leaked, and the ship began to lose lift. The crew barely managed to limp back across the front lines, crash landing in German-held territory. Upon inspection, the airship was declared beyond repair. This mission marked the first serious blow to Germany's military airship ambitions. What followed was even worse. 2 airships, the Z-7 and Z-8, were sent on a reconnaissance mission over mountainous terrain in pursuit of retreating enemy forces. But nature proved just as deadly as enemy fire. Caught in powerful downdrafts, both ships lost control and crashed into cliffs. The crews were killed. These disasters shocked the German command. In just 1 month of combat, Germany had lost a quarter of its military airship fleet, 3 out of the Army's 9. These losses shrank the flotilla and seriously undermined confidence in the Luftwaffe units. Just weeks earlier, airships were seen as the key to victory. Now, their reliability was in question. The early missions revealed numerous weaknesses. Their massive size made them easy targets for artillery. A few well-placed shots could puncture the envelope, leading to catastrophic hydrogen loss and descent. They were extremely sensitive to weather. Strong winds, turbulence, or downdrafts could disable them entirely. Despite their training, crews often found themselves unprepared for the chaotic reality of combat. Piloting an airship required not just technical skill, but the ability to react quickly to the unexpected: enemy fire, sudden weather shifts, or equipment failure. All of this created an atmosphere of uncertainty and dread for those who took to the skies. Each flight was a gamble. Imagine being suspended in a narrow gondola beneath a massive hydrogen-filled balloon, surrounded by darkness and cold, with enemy guns lurking below, ready to open fire. One lucky shot could tear open the envelope, and a crash would likely be fatal. These early operations showed that despite their grandeur, airships were dangerously vulnerable. They could only withstand enemy fire or the elements to a limited extent, and their bulk made evasive maneuvers nearly impossible. Still, Germany wasn't ready to abandon them. Instead, the military sought ways to adapt, refining tactics and technology to make airships more viable in wartime. These early disasters marked the beginning of a new phase, one where innovation would be the key to survival. Following these early setbacks, the German military realized drastic changes were needed. Combat had exposed how vulnerable airships were to both artillery and the forces of nature. If these giants were to remain useful on the battlefield, Germany had to adapt, and so began a period of innovation that fundamentally changed how airships were used, making them better suited for war, but also introducing new risks for their crews. The most significant shift was the decision to fly airships almost exclusively at night. Daylight missions had proven far too dangerous. The airship's enormous profiles made them easy targets for both anti-aircraft gunners and enemy spotters. To reduce visibility, airships were repainted black. Under the cover of darkness and clouds, they became harder to spot and target. This tactical pivot reshaped airship operations, from open reconnaissance flights to stealth missions that relied on night as a shield. But night flying demanded an entirely different skill set. Piloting a massive airship in darkness, navigating by stars, and minimal visual references was incredibly difficult. Every sortie became a test of both technical mastery and human endurance. One of the most revolutionary innovations was the introduction of observation gondolas. These small metal capsules attached to the airship by cables could be lowered several hundred meters below the cloud cover. While the main airship remained hidden in the clouds, one or two observers in the gondola, armed with binoculars and a telephone line, could scout enemy positions and relay information to the crew above. Conditions inside these gondolas were brutal. Observers endured hours of swaying motion, wind, cold, and near total isolation. A snapped cable or sudden gust could mean death. Yet these gondolas made reconnaissance missions more effective while minimizing exposure to enemy fire. Navigation remained a major challenge, especially over the sea where there were no visual landmarks. In darkness or poor visibility, airship crews could easily become disoriented. This was especially problematic for naval airships conducting missions over the North and Baltic Seas. To solve this, Germany built a network of radio direction finding stations along the coast. These stations received signals from airships and triangulated their position using mathematical calculations. Ground crews would then relay coordinates back to the airship. The system had flaws, calculations could be inaccurate, and bad weather or technical issues often disrupted the signal. Worse, it was discovered that enemy forces had similar stations of their own, allowing them to track German airships and prepare countermeasures. Still, these innovations, night missions, black paint, observation gondolas, and direction-finding stations, significantly improved the effectiveness of airships as reconnaissance platforms. They allowed airships to operate with more stealth and complete missions that had once seemed impossible. But every adaptation came at a price. Night flights increased the risk of crashes due to poor visibility. Observation gondolas demanded exceptional courage, as observers dangled between sky and earth in constant danger. Radio stations improved navigation but couldn't guarantee accuracy. Their success relied on flawless coordination between airborne crews and ground teams. This period of adaptation proved that airships could remain useful if they evolved constantly. Germany continued investing in new models, faster, stronger, and better equipped to handle the unpredictable nature of war. Crew training became more intense, preparing them for night missions and sudden emergencies. At the same time, the enemy was improving its air defenses. This arms race of technology and tactics intensified the battle in the skies, where every mission tested both machine and man. Adaptation kept the airships in play, but it also exposed the limits of what they could achieve, and those limits would soon be put to the ultimate test. While the German army was reeling from its early failures with airships, the Navy, under the leadership of Peter Strasser, was charting a new course toward dominance in aerial warfare. After a catastrophic beginning in which the Naval Air Division lost all its airships and most of its trained aeronauts, Strasser set about rebuilding the fleet from the ground up. His determination and strategic vision would eventually turn naval airships into a formidable tool for reconnaissance over the seas. This was the peak of the airship era, when these giants finally began to meet the expectations placed on them. At the start of the war, the Naval Division had only one operational airship, but Strasser had ambitious plans. He oversaw the rapid training of new crews, creating 25 reserve teams ready to replace any lost in action. This system allowed the Navy to recover quickly from crashes and maintain constant readiness. Strasser understood the critical importance of highly trained personnel. His crews underwent rigorous instruction, learning navigation, reconnaissance tactics, meteorology, and radio communication. This methodical training laid the foundation for future success. The Navy ordered dozens of new airships, specifically tailored for maritime operations. These ships featured extended range and could remain airborne for much longer, vital for patrols over vast stretches of water. By 1915, German airships were operating across the North and Baltic Seas, with some missions reaching as far as the coast of neutral Norway. The British Navy maintained dominance at sea, so information gathered from the air was invaluable. Airships detected enemy vessels, tracked their movements, and relayed intelligence back to command. They spotted convoys and warships attempting to hide in fog or behind coastal islands. This intelligence allowed the German fleet to plan operations more effectively and avoid ambushes. Strasser's success stemmed from his ability to react quickly and decisively. Orders for new ships were fulfilled without delay, as High Command recognized their strategic value. Newer airship models were equipped with more powerful engines and stronger structures, enabling them to endure long missions in harsh weather. Some airships could remain in flight for up to 20 hours, covering hundreds of kilometers. This proved especially important for operations over the North Sea, where British ships constantly threatened German ports. Strasser also refined tactics, insisting on tight coordination between airships and ground crews. Direction-finding radio stations became more effective, providing more accurate coordinates. Crews learned to use the weather to their advantage, flying on overcast days when cloud cover made them harder to detect. These tactical improvements allowed missions to be carried out with minimal losses, even as enemy air defenses improved. Naval airships proved highly versatile. They conducted reconnaissance, patrolled sea lanes, escorted German vessels, and issued early warnings of approaching threats. In some cases, they even delivered small cargo or messages to remote outposts. Their adaptability made them essential to naval operations. During missions in the Baltic Sea, airships helped locate Russian ships attempting to break blockades. Their constant presence in the skies created a sense of surveillance that forced enemy forces to act with caution. Strasser's achievements transformed the German command's view of airships. While early army failures had cast doubt on their utility, the Navy proved that, when used properly, they could be powerful assets. By 1915, the Naval Air Division had surpassed the Army in both mission success and crew proficiency, establishing itself as the true leader in airship warfare. This period marked the moment when airships fulfilled their intended role. They became the eyes of the German fleet, delivering information that could shape the outcome of war. But this success also heralded new challenges. The enemy was beginning to prepare countermeasures against these airborne giants. Having proven themselves in reconnaissance, German airships under Peter Strasser soon took on a darker role, bombing enemy territory. This marked the peak of their offensive use, but it also revealed the high cost of their effectiveness. Once symbols of technological progress, airships were now instruments of terror, spreading panic among civilians and escalating a war that was rapidly abandoning its moral boundaries. On January 19, 1915, 3 German airships set off on their first bombing mission against Britain, Their target was a military factory in Yarmouth on England's eastern coast. But heavy clouds obscured the ground, and the bombs fell on the city outskirts instead. Physical damage was limited, with only minor injuries among civilians. But the psychological effect was staggering. For early 20th century Britons, the idea of aerial bombardment was unimaginable. War had always come by land or sea. Now it descended from the sky. Panic swept through the cities. Thousands fled their homes, fearing further attacks. Industrial output dropped as factories lost workers, disrupting supply lines to the front. Strasser, who planned the operation, deliberately chose Britain as a target. He knew the country's distance from the front lines would leave it ill-prepared for air raids. His calculation proved correct. London was forced to redeploy fighter squadrons from the front, and by year's end, over 20,000 troops had been assigned to home air defense. Airships became a nightly menace in British skies, operating solo or in groups. Their constant presence instilled a sense of dread, forcing civilians to live in fear. British efforts to stop them, acoustic detectors, searchlights, and anti-aircraft guns, proved largely ineffective. Intercepting them by fighter plane was no easier. Early aircraft were unreliable at night, and pilots often died in crashes before ever engaging the enemy. 2 months after the Yarmouth raid, it was Paris's turn. In a night raid on the French capital, 3 airships struck a city that had failed to enforce blackout procedures. For over an hour, they dropped several tons of bombs on a brightly lit city. Anti-aircraft fire damaged the airships, particularly the Army's Z-10, which was forced to jettison one of its engine gondolas before crashing near Saint-Quentin. As in Britain, the goal of the Paris raid was psychological intimidation. And the Germans succeeded. Fear of invisible skyborne giants spread through the population, forcing France to revise its defensive strategy. But these attacks provoked retaliation. The Entente began bombing German cities in return. In the spring of 1915, Allied aircraft launched a devastating strike on Karlsruhe, killing 110 civilians. It was a turning point. The era of gentlemen's war was over. Civilian centers were now considered legitimate targets. The rules of engagement blurred, and both sides began regular air attacks on cities. Airships, which had begun as reconnaissance platforms, were now sowing chaos and death, changing the very nature of war. But the price was steep. Each mission carried immense risk: bad weather, mechanical failures, and increasingly accurate enemy fire. Bombing required precision, but poor visibility often led to failure. Crews flew knowing they might never return. Large-scale raids, like the September 3, 1916 attack on London involving 14 airships, highlighted this grim truth. That night, British gunners formed a wall of fire that forced the Armada to retreat without dropping its 30-ton payload. It was the first clear sign that the age of airship supremacy was ending. The enemy had adapted. Despite their psychological impact, the bombings cost Germany dearly. The resources required to build and operate airships often outweighed the damage they inflicted. Human losses, both among aircrews and civilians, underscored the tragedy of this campaign. Airships had become icons of fear, but their true cost raised difficult questions about whether they were worth the sacrifice. The success of German airships in reconnaissance and bombing campaigns forced the Allied powers to radically revise their air defense strategies. In the early years of the war, airships had seemed nearly invincible, but by 1916 the enemy was developing increasingly effective methods of countering them. Growing anti-aircraft power, new technologies, and shifting tactics gradually undermined the dominance of these sky giants, forcing Germany to confront the limits of its machines. This was the beginning of the end for airships as a viable force of war. A turning point came with the introduction of incendiary ammunition, specially designed rounds meant to ignite the hydrogen inside airships. The effectiveness of these weapons was proven on September 3, 1916, when Second Lieutenant William Leif Robinson used just 3 drums of incendiary bullets to bring down the brand-new German airship SL-11 during a massive raid of 14 ships over London. That single victory demonstrated that even the most advanced airships were vulnerable to this new threat. Incendiary rounds punctured the envelope and ignited the hydrogen within, causing rapid destruction. The myth of airship invulnerability was shattered. At the same time, interception tactics were evolving. British fighter pilots, despite flying outdated aircraft, resorted to desperate measures, suspending blades under their wings, dropping grenades, or firing machine guns at close range. While many of these attacks were unsuccessful, they placed tremendous pressure on airship crews. Each ship carried 4 to 7 defensive machine guns, but even this didn't guarantee survival. Night raids, once a protective measure, became increasingly hazardous as British searchlights and acoustic detectors improved. Though still imperfect, these systems started to make a real difference. One of the most critical blows came on October 19, 1917, with the loss of airship L-49. During a failed raid, strong winds pushed 11 German airships deep into French territory. The L-49 was captured intact. The Allies thoroughly examined its structure, uncovering weaknesses that would shape future interception strategies. Entente pilots began targeting engine gondolas and areas housing hydrogen cells, striking where it hurt most. The capture of L-49 was a strategic disaster. It handed enemy forces access to technology that had once been closely guarded. In response, German engineers and Peter Strasser pushed to fly at higher altitudes. The new R-class airships could ascend to over 6 kilometers. To reach such heights, they had to be stripped down, removing much of their armament, reducing fuel reserves and crew sizes, and equipping personnel with oxygen gear to survive the thin air. But these modifications introduced new problems. Engines lost up to 80% of their power in the rarefied atmosphere, making maneuvering difficult and flight stability a challenge. Weather remained a constant threat. Even with Strasser carefully selecting optimal days, wind still took its toll. In 1917 alone, 5 airships were lost after being blown off course and running out of fuel. Army-operated airships, having suffered heavy losses, gradually faded into the background. By 1917, the only remaining operator of steerable airships was the Navy under Strasser. His persistence was fueled by previous successes. Over 2 years, naval airships had conducted 40 raids on Britain, dropping 158 tons of bombs and causing millions in damage. But these achievements were no longer enough to justify continued deployment. The rise of enemy aviation, especially seaplanes and fighters launched from wooden platforms on warships, forced airships to operate at the edge of their capabilities. Each sortie grew more dangerous and losses became frequent. This period proved that despite all efforts, airships could not compete with the rapid evolution of aircraft and air defenses. The enemy adapted faster than Germany could upgrade its machines. High-altitude flights, once seen as a solution, only exposed new vulnerabilities: reduced engine power, physical exhaustion among crews, and total dependence on weather. The age of the airship as a weapon was drawing to a close, and the final blow was fast approaching. The growing strength of Allied air defenses and mounting losses had already cast doubt on the future of airships. But the final blow came with a single devastating tragedy: the death of Peter Strasser and the destruction of the flagship airship L-70. This moment marked the symbolic end of the airship era. Their role in warfare was finished, and aircraft had firmly taken their place in the sky. The fall of their leader, the destruction of their machines, and one last act of defiance closed the chapter on the giants of the air. On August 5, 1918, the L-70 departed on what was meant to be another demonstration of power, a bombing raid over London. On board was Peter Strasser, the relentless commander of the Naval Airship Division who had defended their value through every setback. But over Norfolk, British fighters armed with incendiary rounds intercepted the L-70. The ship was set ablaze and crashed in flames, killing Strasser and the entire crew. His death was a breaking point. Without its driving force, the naval division lost all momentum. No further bombing missions were flown. The airship era was over. Germany's surrender in November 1918 sealed the fate of its airship fleet. According to the armistice, all remaining airships were to be handed over to the Allies as war reparations. But the Luftschiffe crews could not bear the thought of their machines becoming enemy trophies. Instead, they chose destruction. On receiving a coded order, crews simultaneously set fire to 7 operational airships. Flames consumed the vast envelopes, and thick smoke signaled the final farewell. The rulers of the sky had passed the torch to a new power: aviation. This act of self-destruction was both defiance and acknowledgement of defeat. Though colossal in size and capable in their prime, airships were ultimately too fragile for modern war. Incendiary bullets, faster fighters, and ever-improving defenses rendered them obsolete. Their reliance on weather and flammable hydrogen made them inherently risky. On January 5, 1918, 5 airships burned at a repair yard in Alhorn after a single accidental spark. Incidents like these underscored just how delicate and costly these machines were to maintain. Yet the legacy of airships is far from failure. They became icons of a terrifying new kind of warfare. Machines that shattered the boundaries between front lines and the civilian rear. Their night raids on London, Paris, and beyond changed public perceptions forever. No longer was war confined to distant trenches, it could now strike from the stars. The psychological impact led nations to pour resources into anti-aircraft defenses and fighter aircraft. Airships also became a cautionary tale. They showed how bold innovation can be overtaken by the realities of war, where speed and adaptability triumph over scale and spectacle. On the Eastern Front, where airships operated from bases in Warsaw and Jambol, they left their mark across Russia, Greece, and Romania. Weather, not enemy fire, was often their greatest foe. Takeoffs and landings were especially perilous. Their immense size made them vulnerable to crosswinds. To counter this, German engineers developed rotating hangars that allowed safer entry and exit. Later came mooring masts, which made docking easier, but by then it was too late. The era had passed. Enemy aircraft also posed constant danger. Airship bases were prime targets. In the war's early months, a lone biplane destroyed an airship in Düsseldorf with a hand grenade. In November 1918, a bombing raid on the Friedrichshafen shipyard destroyed a nearly completed ship. These attacks forced Germany to move bases inland, made possible only by the extended range of newer models. Still, even this could not save them. Aviation, evolving at a stunning pace, proved more flexible and effective. Planes could strike faster, maneuver more easily, and avoid many of the hazards that plagued airships. Yet airships left behind important lessons on reconnaissance, on the need for air defense, and on the terrifying power of psychological warfare. They also became symbols of a time when humanity dared to conquer the skies and learned the cost of reaching too far. Their end was dramatic but inevitable. Aircraft, once dismissed as primitive, became the future of war in the air. The airships faded into history, leaving only the smoke of their final flames and the memory of a time when they ruled the clouds.